Energy for Mobility Expert Talk. Most welcome back, dear spectators. I hope you are enjoying a nice cup of coffee, sitting in front of the screen. I don't have anything, but I'm around for you today. No matter, no problem. And we still have 4 experts waiting in the background, which will now switch to the screen. Next to me, you'll see them. Thomas Korn, Managing Director of KEYOU, Elena Hof, Program Manager, NIB, the National Organization Hydrogen and Fuel Cell Technology, Dr. Michael Heid, Managing Director of the IDL Anlagenbau Partner Group, and Matthias Braun, Senior Advisor, Aramco Fuel Research Center. Dear experts, are you all around? We can see you already. Can you hear us too? Right, thumb is up, which is good. Mr. Korn, if you hear me, then you can make a head start. Well, I can hear you, but I cannot see any other one. Well, you get the picture. Well, today we have a panel discussion regarding green hydrogen to resolve problems of mobility. Mr. Korn, if you're ready, please make a head start with your statement for introduction's sake. Thank you. The hydrogen engine, the efficiency and the quality for the introduction of clean hydrogen, that's the challenge. It's a great challenge for the automotive industry, and of course also a great chance for startups. And the established forces are of very different opinions regarding mobility of the future. Some say we electrify everything. Well, we can do something in long-distance traffic. Other ones say this doesn't make sense to use hydrogen. So hydrogen is often in the focus of discussions. Of course, the challenge is big in long-distance traffic and commercial vehicles use. And, well, we need to sell 40,000 zero-emission trucks in order to fulfill the goals and to indulge in substitution with hydrogen-based technologies. Pursuant to EU legislation for commercial vehicles, we now have to ask which path we should go, because all the logistics companies and all the other ones have to consider this in their business models. Quickly regarding the hydrogen-based engine, well, what does it make so interesting? Well, first, of course, we have developed production infrastructure over decades to build 80 million combustion engine-based vehicles. And, well, that's the basis to use hydrogen. And of course, the fuel brings a lot of challenges with it, but if you know it, and if you know how it functions, then you can build much more efficient vehicles. The engine can be produced at lower cost in large volumes, and thus it's of extremely high value for customers. Considering what that means, if you compare today's technologies, if you compare 40 tons semi-trailer truck to other ones, then how to sell these 40,000 vehicles successfully by 2030. If you compare to diesel-operated vehicles. Well, of course, these transportation companies have very low margins, and they cannot successfully continue the business models with the same conditions. So there's still a lot of development needed, and many things need to be optimized. And in combination with the superior energy storage, like water storage, everything can be handled much more efficiently with the right systems of storing and distribution in order to avoid CO2 penalties with the corresponding goals. Well, we compared quickly fuel cell-based trucks with hydrogen-operated vehicles. And of course, the use of fuel cell means 5 to 10% improved use, and well, there's lesser effort for cooling. And then, of course, the customers have to decide what counts more, what is the better product for a special application. That's not all a theory, but in industry, the hydrogen-based fuel cell engine has already reached, and their developments with renowned manufacturers throughout the world in combination with different energies for different purposes and applications. And, well, thus I'm already through with my statement, almost. Well, the hydrogen engine is a key technology for speedy mobility change, for the introduction of hydrogen-based mobility, because large volumes can be produced quickly. Of course, we need the right infrastructure with it, and if you can use the full capacity of infrastructure, it doesn't make sense either. So that's the key for all other technologies which will come: hydrogen storage, hydrogen-based fuel cells, because we need to establish the links to all the directions in which we want to move. Well, and this is already the end of my presentation. Thank you very much for your attention. Mr. Korn, Managing Director of KEYOU, we'll now come to the next statements. Of course, there are also some questions already in the chat. I also have a few for you, and I think we'll have a nice discussion until 17:30. Well, Elena Hof, I'm happy to have you here already, Program Director of NOW from Berlin. Your statement, please. Thank you for your announcement. I have some problems with the charts. Of course, there's all the information. Maybe it's too much anyway. I want to talk about the areas and sectors where hydrogen shall be used. In transport and traffic, well, we move in our own bubble, and then there's the discussion where to use hydrogen at the end of the day. For that, we need to understand that everything has to be interlinked properly with all the details. I looked for an example, the context of the harbor and the harbor logistics, to show how versatile the roles are in an integrated system, especially including energy. Let's focus on hydrogen for a start, and various potentials for use. For example, the power supply of a ship for the propulsion of the ship, but also to import hydrogen to Germany. So if such a ship reaches in the harbor, it may be that it is replenished with locally produced hydrogen in Germany, but it may also be that it reaches through other channels. And, of course, it can be used in the steel industry too, or in mobility, in transport and traffic. And at the same time, the hydrogen is also used in harbor logistics, in stationary fuel cell applications, but also to transport goods on other ways. And hydrogen can also be used to replenish trucks or goods trains. and they transport the commodities on to logistics centers, and their intralogistics is used, or stationary energy supply. So what I want to show with this is that it all makes sense to consider all these factors and interlink each and everything. And the need to consider the entire system of energy and how things are linked with one another in detail, and how we can use effects of synergy. Right. Thank you very much.
This was certainly a helpful slide, helpful for many of you, dear viewers. It gave us a great overview, and we are going to discuss about the details in a minute. I can see a couple of questions in the chat. So we are in for an exciting discussion. EDL is next, Dr. Hyde. We haven't met in person yet. It's so great to welcome a new face to the hydrogen world. EDL systems of the Pörner Group. What do you do in the field of hydrogen? We are really looking forward to hear about it. Can you hear me? Yes, I can. Wonderful. I can see our presentation, and I hope that you can see it as well. Yes. Well, to begin with, in terms of focus, I had prepared this presentation to cover the aviation sector because aviation is most difficult to decarbonize in terms of greenhouse gas emissions. There are various commitments to not expand carbon emissions after 2020 anymore. And at the bottom line, it all depends on what fuels are available, because hydrogen and electrical drive systems, as we have heard, will be a solution in the more faraway future. So we have to restrict ourselves to what is possible now. Liquid fuels such as kerosene or aviation fuel, and their sustainable type is called SAF, or sustainable aviation fuels. In the US, there are many biomass-based activities, and you can see them in the slide here. There are various pathways towards production of SAFs using biomass or power to liquids. This is something that is certainly on the rise, also in terms of certification, because these fuels really need to be certified to be used in aviation. In this slide, I illustrated our prediction for 2050. The dots show the different types of fuels, and in green you see the sustainable aviation fuels. Blue dots represent hydrogen, and red dots represent electric energy. So by 2050, 80% of today's aircraft will still be in operation, and they can only be moved by liquid fuel. This is an overview from BP, an overview of the development of different aviation fuels. There are different pathways, as I said. The top section, light blue, these are e-fuels. By 2050, they are going to account for a significant share of the overall aviation fuels total. Next, we see additional pathways for those e-fuels or PTL fuels. This slide was taken from the PTL roadmap of the federal government. And one of the main focal areas is hydrogen, next carbon source. Fischer-Tropsch is another route. E-fuels or kerosene fuel or other areas of transportation. PTL fuels or e-fuels are approved as drop-in fuels. they can be added to an amount of 50%. And they can lead to a high greenhouse gas mitigation effect. We have developed products and technologies for the HYKERO system, or HYKERO plant, that's what we call it. Renewable electricity, green methane, etc., are used to produce naphtha, kerosene, and hydrogen. We are currently in the process of integrating the system at a site in order to make use of synergy effects with the advantages of the location. We are based in Saxony, not far away from the airport, 30 kilometers or so, so a truck can be used to transport the fuels to the airport without increasing the emissions level substantially. Even today, PTL kerosene can be produced here. My contact details can be found in the presentation, so I'd be very happy if you got in touch with me, and we can discuss the technologies in greater detail. Thank you so much, Dr. Heid. Now, for those of you who did not understand what SAF is all about, SAF is Sustainable Aviation Fuels. So we actually read it out once before we move on to our last presenter on the panel. He is going to give us a brief introductory statement. Matthias Braun, I know you are here. We are going to see you in a minute. He's a senior advisor to Aramco Fuel Research Center. And now you're good to go. Thank you very much indeed. Thank you to Messe Frankfurt, a global player, for opening this platform. These topics can be mastered only if they are tackled at a global scale, and Aramco wants to contribute to this. Aramco is the biggest oil producer in the world. $32 billion of turnover, one of the three most valuable companies in the world. So the company is owned by Saudi Arabia. And as many know, Saudi Arabia has concluded a hydrogen agreement with the EU and specifically Germany, because we hope that the tremendous demand for energy that we have in the northern countries can be covered by the countries that are rich in solar power, such as Chile, Middle East, or Africa. You must have heard of Desertec, I'm sure. Those countries have great advantages. They have less population density, and they can afford to export energy. The production cost is very low. Saudi Arabia has a world record of 1.04 euros per kilowatt hour. Sorry, 1.04 cents per kilowatt hour. So they can afford to allow for inefficiencies here, but they want to balance these out, and Saudi Aramco has decided to build a competence center for innovative fuels in Europe, because Europe is where the industry is, where the competencies and skills are, the research institutes, the universities. So they consciously decided to set up this institute in Paris. What they do in Europe is they have two large demonstrator plants for large-scale series production. Both factories produce millions of tons of synthetic fuels every year. One of them is based in Neom, the future city in Saudi Arabia, Ram, and the second one was located in Spain, Europe. These demo plants will be starting production by 22-23, so by 24-25 we will be able to see what is needed in order to ramp up volume production. And we do need volume production, as has become pretty clear. Let me quote the CEO of Porsche, very active together with Siemens Energy in South America. They say we will will need 10 years until we have fully ramped up production, so we really have to make an effort now. Time is running, it's running for me, and it runs when it comes to coping with climate change. Saudi Aramco have said they want to become the #1 global hydrogen exporter. Thank you.
Thank you very much. Let me now look into the chat. Mr. Siegmann, general question. What do the mineral oil companies say about this? Well, if you want to have a more tangible question, please put it in the chat again. Now a question to you, Mr. Korn. Let me read it out. When will the first vehicles, respectively engines, come to the field? While we are a technology supplier, we support engine and vehicle manufacturers, also in the development and enhancement of everything. And well, in an 18-ton truck, for example, we'll present what it is able to do. We build up the startup situation in combination with a hybrid and hydrogen fuel cell combination makes really sense. A city bus will also be presented next year. And there's still another project which still need to be authorized for semi-trailer trucks to be put on tests in 2-3 years. And they're also tested in everyday use with various customers. And we can thus study where this technology has advantages and disadvantages. Still another question, which is certainly meant for you. If ASTM was to be adapted, then a mixture of 50% would also be possible, would it? Well, I think the question is not to use 100% hydrogen, but to use it in combination. Well, we use hydrogen to the tune of 100%. We use all the properties, the energy combination in combination with carbon, different fuels. Of course, we use the combustion process with 100% hydrogen. For us, biofuels are already relegated to the past. Well, if the question is clicked away, we proceed with the next one. Ms. Hof, I think this is meant for you. Quite a long question. Well, it's undisputed that wind and solar energy will never be enough to guarantee the full demand for hydrogen. So why is there no more talk about the production of green hydrogen, although this offers much more potential? I don't know whether I'm the real expert in this field. I'm dealing mainly with the use of hydrogen, not with the production. Of course, there are various options of hydrogen production. In our case, in NOW, there are ongoing discussions too, and it's also a matter of rules and regulations, legislation, and the question is also how the EU defines green hydrogen. That's still a problem of definition. And of course, I cannot influence this, so I cannot really comment on that. Regarding the importation of hydrogen, well, that is also something which many people view critically, saying, well, if we cannot do enough local green production, then, well, what to do? Should we import it from Russia? Well, you cannot really shock the world with this. Green hydrogen being imported from other countries to Germany, which, of course, is a challenge. But, of course, we can get prepared for the challenge in the course of the years. Maybe one addition on that, from my view. Renewable green means sun and wind, and this is available without limits. There are no limits at all. Well, if I may comment on that, well, Aramco must know it. There are calculations according to which 8% of the desert areas equipped with solar cells can replace our today's consumption almost completely. Well, then there's a reactor in a safe distance. We call it sun. And, well, not only renewable energy and all the hydrogen storages, if all of that is used, we can bring about the energy and climate turnaround. There are also studies on our structures, how the hydrogen is brought from Morocco here in large volumes. There are also intermediate studies regarding liquefaction and transport on vessels, or how can this be compared to a situation in which pipelines would be produced for this purpose. So in the future, of course, everything will only work properly in combination with hydrogen. Well, now another question going to your direction. Should blue and green hydrogen be put on equal footing? Well, I work in Paris purely on the basis of green hydrogen, only sun and wind. Well, that's a good catchword, Dr. Haidt. I have one question for you. We talk about the various options in combination with mobility. Why do you put your stake mainly on power to liquid to operate aircrafts? Well, aircrafts with hydrogen electric drive, well, those are things which may come true in 30, 40 years only. And before, of course, we also need solutions. As we have seen, the carbon budget is finite. Hence, we would have to start as of now to use existing infrastructures. And with PTL kerosene, this is feasible. And there, too, we have possibilities to do this with a high degree of efficiency and to realize high greenhouse gas savings. It, of course, depends on availability all the while. Okay, let's continue with a question from the chat. Now it has disappeared. David Bischoff had a question to Mr. Korn. What about the injection pressures, in technical terms, into the fuel cell in the long run? More than 50 bar, more than 150, more than 300 bar? Well, the engine technology is connected to the storage. The vehicles of the future will have production characteristics dominated by the drivetrain in the first place. The question is how the hydrogen gets into the vehicle and how it is stored there, because this will also define the injection pressures. So we need to consider the entire ecosystem to take the right decision at the end. At the moment, we have two different technologies in development, and we have internal and external mixture formation, sucking in with a pipe, and there's we rather talk about average pressures instead of high pressures. And this is what we have chosen because we think that's the direction in which the hydrogen development will go. Now a question to Matthias Braun regarding hydrogen production. If you want to be number one, where do you get all the water you need? Well, of course, Saudi Arabia, of course, also has its desalination stations and everything belonging to it that's available with European top technology. And, well, this is a challenge, but the goals can certainly be realized. So let's stick to the producers. Ms. Hof, I don't really know your actual subject matter. We also come to application. But Mr. Siegmann wants to know says that Shell also wants to become renewable. Yes, I can confirm this. They had a nice seminar course on that in April. Well, BP is not that clear. But what about the other ones? Have you realized everything at NOW in that regard? Well, I can talk on behalf of those active in the hydrogen infrastructure. Of course, there's Total, OMV, not really mineral oil companies. Well, BP, well, yes. But in the hydrogen world, it's mainly companies with focus on filling stations on the supply of the respective energy. Those are the main players. Well, apart from that, the chat helps like always, and we also have spectators paying attention. So if you can tell us more names for this purpose, please tell us. And another question on Dr. Hyde in the meantime. Until when HYKERO shall be able and produce the large volumes needed for kerosene? Well, at the moment, the location design shall be integrated in the industry locations to get economies of scale. And then by the beginning of next year, the engineering can be started. And then by 2025, the station can be commissioned and go into operation.
From aviation to the road, Ms. Hof, how mature is hydrogen technology today, and from when on will we see large vehicle fleets on the road? Well, it depends on what application you talk. When it comes up to market maturity, it's about feasibility, safety, and scaling up. There is a large share of development going on in heavy-duty truck transport. Next year, we will see the first vehicles on the road, but later on, we will see entire fleets like in 24, 25, and by 2030, we will see the truly large volumes, and we hope that it will happen earlier. For rail-based traffic, we have made faster progress. We have fleets of hydrogen-driven trains that will go into operation next year. And in aviation, we have some small-scale solutions, individual small-scale aircraft that are really flying on hydrogen. But it will take some more years until we can see large numbers of hydrogen aircraft. It's about scaling up production now rather than proving technical feasibility. Okay, so let's stay with the means of transportation, various technical directions. What is the consumption level for compressors of a hydrogen refueling station in percent of volume refueled? Anyone who can answer this question? Well, we do have some compressor manufacturers such as Neumann and Esser. They could answer your question immediately, but unfortunately, they are not part of this panel. Well, ultimately, it's all about cost. What is the price at which refueling stations can offer hydrogen? You have CapEx and you have OpEx. Production price, infrastructure cost, transportation cost. What is the refueling station like? Is it a high pressure or a liquid hydrogen refueling station? In the former case, you need a compressor and you want €5 per kilogram. That's what the green hydrogen price should be like. And then that would make it competitive compared to diesel trucks. But you cannot really look at this as a question of a single component at the refueling station. Instead, the entire environment has to be designed in such a way as to make it feasible. When it comes to compressor prices, I can tell you from my own experience, there is a lot going on here. So you have to plan and design very well in order to have the right compressor for your specific application. And as Ms. Hof mentioned, in the three-stage model, we can see now in real life that this is a place where we need some readjustment. Readjustment is needed here and there, and you are the experts to do just that. I have another question aimed at Mr. Braun. This is about hydrogen production and in particular solar production. Who is going to build all these solar panels? 4.5 million cubic kilometers? No, it must be square kilometers. Yeah, square kilometers. Is China going to build them all? Well, now you've asked a question and you've given us part of the answer. There is a very strong solar panel industry in Europe, including Germany, but the Asians really took over this market. We subsidized it, and they actually took it. It's not just China and Korea, it's Japan as well. They are very interested in these fields, and they are certainly going to gain market share. Heavy-duty trucks and transportation. We talked about trucks before, and now let's move on to the maritime area. Christopher Lorenzen from MAN Energy Solutions talked about the maritime aspects, but let me actually render the question asked by Lucas Ross. Cargo shipping, cargo transportation by sea is going to play a key role. Shouldn't much higher efforts be undertaken here? I would say yes. In the maritime area, above all, we see a lot of research and development going on. This is a hot topic indeed. In the past years, it was all about heavy-duty road-based transportation, and now aviation and maritime applications are up and coming. And that's why I chose the picture from a port context to show you, because I think it's extremely interesting, not just because of the maritime users, but also because of the various port-based applications and elements. So it is certainly a very interesting area to focus on. Right. Now, again, let's move from the maritime area to the components. Mr. Korn, a somewhat longer question. Well, let me read it out, although it's a little intricate. Josef Rumlal, a stationary engine designer, said that because of the higher combustion speed of hydrogen, the operation of stationary systems is possible only to a limited extent. Wouldn't that actually limit the use of onboard truck hydrogen construction? Yes, it's not so easy to optimize hydrogen combustion in an engine, but it is doable. It is doable indeed. There are no limitations of any functional kind. The hydrogen engine can be installed in any structure where you would normally install an ICE. It is much better than the diesel because it's emission-free, carbon-free. It will have a higher efficiency level, and it has a potential. This is the challenge everybody's working on. How can I enhance the specific power density without increasing NOx emissions or without compromising on efficiency? This is really an art. And it is a development that will take several more years because the best hydrogen engine has not yet been built and developed, and everybody is working toward building it. There are limitations, but wherever you have diesel or standard fuel ICEs, you can install a hydrogen ICE. But why is it just now that you are building the hydrogen engine? After all, it's not totally new and disruptive. Well, like all the other automotive technologies, think of e-mobility. It is a very old technology, more than 100 years old. In the 80s, they tried to roll out e-mobility, and now the boundary conditions have changed, and that's the precondition for it working. The last time hydrogen ICEs were developed, well, that was 15 years ago. BMW led the race back then, but now the situation is different. We have to speed it up. Climate change is something you cannot negotiate away, and we have emissions legislation that makes it absolutely necessary to enter the market quickly with large numbers. And the hydrogen economy will benefit from a large number of consumers, because only if you have a large number of consumers, you can really affordably build an infrastructure that will pay off. And the more consumers you have, the more feasible it will become to have a hydrogen pipeline running across Europe. Okay, now we are nearing the end of our panel, and let me check what other questions there may be on the chat. The salt levels in the sea are a topic. Well, that would actually justify a separate event. Environmental issues, because we will need large quantities of seawater. Well, I think it makes sense to discuss this in greater depth at another event. What else is there in the chat? Well, Dr. Haidt, there is something for the chemists among us. I'm sure there are some chemists listening in. I am not a chemist for sure, but certainly some members of our audience will be happy about this. There are many procedural approaches for producing SAF. Why do you opt for the Fischer-Tropsch method? Well, there are various drop-in fuels that have been approved in line with ASTM. Fischer-Tropsch is one of them, but synthetic gas as the pre-product for Fischer-Tropsch and the subsequent kerosene production are an ideal pathway in combination with direct air capture, with actually obtaining carbon dioxide from the air. This enables us to provide a completely sustainable kerosene production cycle for direct air capture. What is so interesting here is the question, where does the water come from? In parallel to carbon dioxide, we also obtain water, which we use for electrolysis in our process. So for the process that we are running or planning two demonstrators for, one based in Mecklenburg-Vorpommern, another one based in Saxony, we will not use any additional water. Instead, the water would be obtained from the air.
Right. If there are no fresh questions coming from the chat, I have a question meant for all. Let me start with you, Ms. Hoff. You are the one who has the complete overview of it. The question is, what is the biggest challenge with a view to the market phase-up of hydrogen mobility? Well, there are two major challenges. One, the scaling up. We're actively promoting the components development. Of course, there are also investments or contributions for projects to the tune of a few million. Of course, it is only a drop in the ocean in comparison to the production requirements. So the decision must be taken to scale up and then to develop the preconditions for the necessary volumes. Then we also need more in infrastructure. We have a good filling grid for replenishing passenger cars, but of course in trucks that is a totally different challenge given the volumes. Then hydrogen quality measurements at the filling station, the legislative framework, which also need to be designed accordingly, given all the challenges. Who wants to continue? Let me continue with Mr. Korn. What do you think? What's the biggest challenge for the market run-up? Well, of course, the product must be competitive as compared to the benchmark, the diesel vehicle, when talking about mobility. It must be competitive. The vehicle belongs to it with its right technology, and then, of course, also the fuel with its infrastructure. We have briefly mentioned it and asked where the green hydrogen will be used first. Well, this is not decided by anyone pushing a button, but it is answered where most is paid for the hydrogen, because finally it's also business at the end of the day, especially when it comes to scaling up. And mobility, well, can certainly initiate all the things. Of course, it would also be nice if we could decarbonate with hydrogen, but probably we couldn't demand the right price in this context. So mobility must be the focus at the beginning in order to supply enough hydrogen also in other fields. Well, what about your final statement for the market run-up? Well, from my point of view, there are many developments in new technologies in order to support this run-up phase on the market. But of course, there are also sufficient technologies where you can realize things immediately in a commercial dimension. What is lacking from our point of view is the legislation which shall create the foundation and which would guarantee long-term investment by the respective companies so that it makes sense in the long run. And more recent topics like PTL, power-based fuels, there are still a few gaps which need to be closed as quickly as possible in order to provide safe investment. Thank you very much, Dr. Haidt. And last in line here, in this hydrogen round, Mr. Braun, of course, it's now time for your final statement too. And in 2 minutes' time, we'll already close our virtual round. Well, challenge with a view to the market run-up of hydrogen in the context of mobility. Well, we have competence and know-how, the capacities of human beings. We need less dogmatism, and we need to take the people along early on in the process. Well, in Switzerland, higher fuel prices have been rejected, so we should take along the citizens more and be less dogmatic. Well, take along the people, well, that's a good clue, because that's what we did with you today. Well, you will certainly be given a live figure too of the people who have been with you in the boat today here. Thank you very much once again, most cordially, our 4 experts. Thanks a lot for being with us. I'm happy if we meet again, if we could meet again virtually and hopefully also live and in color. And if you have questions to our participants, please approach us.